Corporate Finance Practice Problem using Excel. Modified Internal Rate of Return, the MIRR. Get ready, it's time to take your chance with Corporate Finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet and would like to follow along, note that we're in the Practice tab as opposed to the Example tab. The Example tab, in essence, being an answer key. Information's on the left-hand side. We're going to populate that information into the blue area on the right-hand side. We have another situation where we're thinking about putting money down and getting a return in the future, multiple years into the future. Therefore, we want to take into consideration typically the time value of money, primary tools to do that, the net present value calculation, and the internal rate of return calculations, things we concentrated on in prior presentations. This time, we're going to modify the internal rate of return. So scenario here, we have the investment of the $100,000. That could be for equipment. You could think of equipment. You could think of inventory. You can think of a project, something that we're putting money down on to get money back in the future. And then we have the cost of capital, which could be called the required rate of return, the hurdle rate, 15%. And then we're expecting the future cash flows to be $50,000, $34,000, $39,000 for years 1, 2, and 3, respectively. Now, what we want to do here is to take into consideration the fact that when we get this money back, we're going to be reinvesting it. And when we reinvest it, we're going to reinvest it, and we believe that as we get the money back, we'll be able to reinvest it, getting a return of the cost of capital, the 15%. So we want to take into consideration, as we think about this project, not only the fact that we're going to get the return related to the project, this cash flow, but also reinvesting that cash flow, getting a return after we reinvest at the 15%. And then think about what the modified internal rate of return is for this time period, for this set of circumstances, this set of flows, given that assumption. So first, we want to think about what the future inflows will be, the future value of the cash inflows. So that's going to be these inflows here. We're going to say period 1, 2, and 3. Going to sum them up. We're going to go to the alignment tab, center them. I'm going to put the total on down below, T-O, total. You know how to spell total. I don't need to spell it out here. And then we're going to have our series of payments, which is going to be the $50,000. I'm going to copy that, Control-C, down arrow, Shift, holding down Shift, down arrow, Control-V, pasting that, underlining the bottom one, font group, and underline. I'll sum that up, equals the SUM. And there's going to be our flow of inflows, assuming no time value of money taking place at this point. Now we're going to try to figure out the future value this time, considering or assuming that this money that we're getting, we're going to be putting back into some investment for a 15% return, which is our cost of capital. So as we do this, remember, we're kind of now projecting out into the future. We're not discounting to the past. We're going to end up with a number of where we would be at the end of 3 years in a future value. So let's take a look at what that might look like. If I had the $50,000 here, then I'd have 2 more years that I could basically invest it back in place for the $15,000 for years 2 and year 3 for the time period of this project. So we can calculate the future value looking like this: negative future value FV shift 9. The rate's going to be the 15%. I'm going to make that an absolute reference by selecting F4 on the keyboard, $ before the B and 3. And then going to put the comma. The number of periods I'm going to do it this way so that I can copy it down. Period 3, making that absolute, $ before the D and 4 by selecting F4 on the keyboard, minus the 1. When I copy that down, then this one will stay constant. The 1 will move down. You can see it'll calculate, in this case, to 2. 3 minus 1 is 2, because we have 2 years for that $50,000 to grow within this same kind of time horizon. Comma, then the period, no period, comma, we have then the present value of the $50,000. Let's do it again. Negative future value, shift 9. We're going to pick up the rate, the 15%. I'm going to F4, assuming or practicing if I wanted to copy that down. $ before the B and 3, comma, number of periods. I'm going to take the 3, make that absolute by selecting F4 on the keyboard, $ before the D and 4 minus the 2, which we are on. That means 1 year remaining, because at this point in time, we have 1 year to get a 15% return given this set of circumstances, comma, comma, Then the present value is going to be that 34. Let's do it one more time, and then we'll show how to copy it down and just prove that it does work to copy it down, because I think there might be some people that are doubting, and we want to disprove the doubt. I don't know. So we're going to say the 15% F4, comma, and then number of periods is going to be the 3. I'm going to say F4 minus 3, which is 0. And then we're going to say comma, comma. The present value is the 39. Same number there, because obviously we have no future investment. That's the end of the 3 years. Let's copy it down and see if it does that same thing. I'm going to do this again one more time. Negative future value, shift 9, the rate 15%, F4 on the keyboard, making it an absolute reference. $sign before the B and 3, comma, number of periods is going to be 3. F4 on the keyboard to make it absolute, minus the 1, which will not be absolute, comma, and then the 50,000, one more comma, hold on, one more comma, and then the 50,000. So the 50,000 is going to move down, the 1's going to move down, this will stay constant, that will stay constant. Let's do it. Let's do it. Autofill, handle, dragging it down. Let's double click on the last one, see if it does what we expect it would. Does it? Yes, it does. Indeed. So let's go ahead and then underline this font group and underline and sum it up. Equals the SUM. And sum that up. So we got the 144, 229, now 225. Now that's the future value now. And what I'd like now is to figure out the internal rate of return given that assumption. So the internal rate of return, we can basically think of it as the rate at which this future value would be equal to the 100,000 present value, because it's the one lump sum future value. So that's going to be the calculation that we're looking for. So we can do that using goal seek, I think, is one kind of intuitive way to do that. You can also look at a formula that would look something like this. The present value equals the future value divided by 1 plus MIRR to the number of periods, and that would look something like this. The present value being the 100,000, the investment, equals the 144, 225. That's our future value, divided by 1 plus the MIRR. This is what we're trying to find, to the power of 3, in this case, the number of periods. I'm going to first do it with the goal seek, and I think that's kind of the more intuitive way, and then we'll do this calculation on down below. I won't do it algebraically. You can do it algebraically, then solving for the MIRR here. I'll do it with a table, kind of a goal seek fashion in there as well. So we're going to say then we have I'm just going to put a number here for the goal seek, for the MIRR. Let's just say 10%, for example, 10%. And then I'm looking for the present value. So I'm going to do the present value calculation. I'm going to use this 10%. And then I'm going to ask Excel to change this percent to whatever it needs to be in order for this cell to equal the 100,000. That will be our MIRR, or the modified internal rate of return. So let's go. This is going to be the negative present value, shift 9. The rate is going to be that rate that we guessed right there, comma. Number of periods we're going to say is 3. I'll pick up over here, 3 periods. And then comma, comma, future value, because it's not an annuity, so future value is going to be that 144, 225, about. That might be rounded. And we get to that 108, 358. Now, what we want to get is to that 100,000. So I could say, well, what if I change this to like 11% and so on? Or we can ask Excel to do that for us. So let's do that. Excel, will you do that for us? Excel's like, my pleasure. We can do that. We go to the data tab up top to do so. The forecast group, what if analysis, and then we're going to say that we want to set this cell to be 100,000. 100, is that enough zeros? 1, 2, 3. Yeah, that's the right amount of zeros. By changing this cell right there. So we want to set that cell to be 100,000 by changing that cell. And okay, and it does it magically. So it kind of just forces it to work. It just does just what we did, but it does it really fast. The 12.98. So that's going to be the MIRR then. So let's do it with the formula down here. I won't rework the formula algebraically. I'll just do it in the same kind of fashion we did here, just putting that formula into a table type of worksheet. So if we had the future value is, we said, this 144, 225, and then I'm going to pull in the 1 plus the MIRR to the power of 3, and that's going to be the 1, and then the MIRR, and this is, of course, what we don't really know at this point, so we could do the same kind of thing in terms of a goal seek, 0.1, or of course, you could work it algebraically, you know, do your algebra up top. I'm going to go to the Home tab, and doing work in the algebra doesn't work that well in Excel. That's why I don't do it. So solving for that one unknown is a way to go. So keep that in mind too. We're going to go to the number group. We're going to percent it. I'm going to make that yellow, and then let's underline it, and we'll call that the subtotal. Summing that equals, summing that up. Let's indent this one. Go alignment, indent. And then we'll percentify this cell, go into the number group, make that a %. And then we have the number of periods, or N, which is going to be, we're saying 3. And we're taking it to the power of 3. 3 is powerful. And we're going to the power of 3. So then we have a subtotal again. Subtote. And we're going to say 110%. Shift 6 to the power of 3. So caret power of 3, making that a %. Numbers group, percentifying it. Underline font group and underline. That's going to give us the future value, which would be then equal to this divided by that. And once again, we need this number to be the 100,000. So we could change this again to like 11% and so on. I could use goal seek to do that. So let's use goal seek to do it because that's fun to do. So we'll go to the data up top. Forecast, what if we sought the goal? What if we sought this particular goal to set this cell to be 100,000 by changing this cell? And what if we set that goal and said, okay, then we'd get about 13% again. And if I add some decimals, Home tab, number group, and decimals, we get to the 12.98. So another way you can kind of visualize this, probably much far less common problem than the internal rate of return itself, but you might see it, and you can see why it could be an interesting kind of assumption to make as you make different assumptions about future cash flows, and it might be something you mull over as you're considering different projects and considering the inflows that are going to be related to them and whether or not you can invest those inflows and what the rate you would be able to invest those inflows could have an impact on the decision-making process between multiple different projects.